Okay, so I think we got most of our peripherals connected and our analog devices. So next we have pretty much power. So power is very, very important in PCB design. To make good power connections is quite difficult, but one thing I want to say that's important is that our signals are very susceptible to noise. Our power lines can be noisy, but the integrity of our signals is extremely important. The power ones we can weave using vias a little more frequently. I'm not saying it's the best thing to do, but it'll be less detrimental than if we had to do it with our signals all the time. Let's do route. We're gonna make our power traces thicker, really thick, so maybe about 30 mils, between 20 and 30 mils where possible. Of course, this depends on the size of your pads or so. We don't want them to be bigger, so these ones will probably make slightly smaller. But from our battery, we should make this one as big as possible. So 30 mils making that connection. One could argue this might be a little close to here, it might interfere, so we'll do it like that. So these are as far away as possible. We can also massage these outward too if they're in the way. So let's do 20 mils for these guys. And then let's see, let's show 3.3 volts. We got to make all these connections here. All these guys take 3.3 volts. For the analog and our LED here, we probably won't need that thick of a trace. And ideally I want to go through here too, so that must have been why earlier I said I've rotated this. So I'm going to use rip to rip some of these guys. I'm going to rotate it over. Route 6 mil. Good. And then for the MCU, for the thumbsticks and the LED, the power LED and the Bluetooth, it doesn't need 20 mil traces. We will try and use 20 mil where possible because the thicker the traces, the lower the impedance. But here we're actually going to branch out a couple times. So route 20 mil, we'll go down here. And we'll go back to that soon, but let's concentrate on the devices over here real quick. So let's do route maybe 10 mil. And I'm going to do it on the bottom. I'm going for this LED. Go on the outside so we don't interrupt our ground plane as much as possible. And then since we need to come up on the top, we'll place a via, make it nice and close. Good. So again with the massaging, I want to push this over. Notice how we broke the ground plane here a little bit. So that should be fine. Do another rats and it's nice and filled. So we won't be able to save face everywhere. I mean, we can get really meticulous and make another connection here, but this is perfectly fine. It'll work. These look good. We could probably even push this down a little bit more, but this looks fine. All right. So let's do the rest of our 3.3 volts. So I would like to take our 20 mil through here, but I have a feeling that it'll be too thick. Yep, so what we can do is we can make it smaller, or we can move all this stuff up a little bit. So I'm gonna go with moving, and this is probably a good example where things are gonna get a little stuffed up, but it's fine. We'll just show you how to fix that. And when you do your design, this is where careful placement matters and just part of the iteration procedure. So let's put this as high up as we can. Let's make sure this fits through. Should be fine now. And we'll put it here, and then let's fix the routes we have here. Massage it out a little bit if you want, you don't have to. And oh, here we go, I got a little messed up here. Make one more junction here. I thought something was a little strange. I seem to have moved everything outward by one tick. Now the DRC isn't yelling at me. If I group, I can move this out together. Good. Anything else? When I moved it, these got massaged out a little bit. There we go. Looks pretty. It's okay if these are crossing. He's got a little nub here. Kill that. So let's complete this. And what I'm actually gonna do is I'm gonna pull this out a little bit, and then about 20 mil. and then I'm going to route 10 mil out of here along the side. And the reason why I make these separate branches, it's called star branching, is so that like the noise doesn't carry from device to device. But I want my microcontroller to be nice and clean. For these guys, I mean, it'll still be relatively clean, but I don't want the effect carrying to each one. So I'll connect that, and then this one's going to go all the way to our Bluetooth. Let's just push it down a little bit. I think that's good. All right, let's zoom out here. Rats, DRC, what do we got left? So just 2 more connections, one right there and one here. So our reset cap has to be connected to 3.3 volts. So luckily we've been minimizing the number of vias as possible, but we will have to use one here. So route 6 mil, this doesn't need a lot of power going to it. Via to the bottom, and then via back to the top here. Good. So that should be fine. Let's maximize our ground plane. We can either move this way or the other way. You'll notice how this keeps on getting bigger. What we're going to do in a moment is actually just put a via here so we get a little bit of ground plane. Probably won't be doing much, but the more ground plane we have, the better in general. We can if we want, totally optional, but since it's reaching out to me, this little nub of ground plane won't do much. So I'd rather make a tighter connection here. No use putting a via there, but it may be useful to put a big one right there, or one to make it bigger right there. So this looks good. We have one more air wire, and it's this guy. This shutdown pin, if you can recall, it won't have a lot of power flowing through it, and you can verify that from the data sheet. So I'm going to make a small connection here. So let's do rats, DRC, and again, check. We see that we have a wire stub, so let's kill that. Rats, DRC, and we see that we only have a couple of keep out errors. Let's check those out real quick. So I said already at the very beginning when we place this that this will be fine, so I'm going to prove it so it stops bugging me. It says we have a keep out issue here. This will be fine. Again, I'm just trying to make things small. Maybe we could, shift everything over, but we've come so far. Should be fine. But again, just be aware for your own design when you can bend these rules and when you cannot. What is it? Oh, it's just another point of contact for that T keep out, and there's one down here as well. It's going to yell at me. So approve. So that's great. We have no errors. So if we do DRC again and check, it'll tell us we have no errors, or we have 8 approved ones, and that's fine. So we're pretty much done. Technically we have routed everything, but there's a couple of things that I'm going to go through that are really important. Alright, so we got to add some swag onto here. So let's put some text to show the name of our device. We'll make it maybe 1.5 size, 20% ratio, font vector, bottom line just fine, but I don't want it on the top layer. You could do some cool art where it'll actually show like a copper display of your device, but we're not going to do that. We're going to put on T place, and we'll place it. And the next thing we want to add is a revision number. So text rev 1, and I like to make these a little bit smaller, maybe 1, maybe smaller than that. 10% ratio, I don't want it to be super thick, and find somewhere else where it can fit. And then that's good for the top. For the bottom, I'm going to switch over here, flip the board. I'm going to add design by. I'm going to make this much smaller, and I want it to be on the bottom, so it'll flip it over, and I want the size to be 0.5, a lot smaller. I'm going to put it in a nice empty location, maybe here, and then I have a logo for my Mr. Swirly Eyes, so I'm going to drop that here. By default, it's on the top layer. I mirror it onto the bottom layer. Then I'll move my design by over here. And some people will see this character and not know it's me, so I'll put my name, Mr. Swirly Eyes, down here maybe. Of course, you can change this for yourself. We'll have a tutorial up that'll show you how to make your own one of these guys, but for now, you might just want to put design by and then your name. And then we got to add our PIB swag. We got to mirror it first. Oh yeah. Okay, so that was just some of the swag, but we actually got to do some real work. So I told you guys I want to fix the ground planes here, and so now it almost seems like we added the text here and it's kind of in our way, so let's get rid of that. So we'll do display minus T names, display minus T place, display minus T docu, and then for the bottom, display minus B place, display minus B names, display minus B values, and bring back T place and bring back B place. One thing I meant to do a lot earlier is actually I wanted to put this on the bottom. If we do change layer top and then click on the blue wire, it'll change it to the top layer. We still got to move this around a little bit. And so rats again. Cool, little side detour, but that's on the bottom, which is how I have it for your guys' PCB board. It's probably easier so you don't have wires sticking out of here later. Okay, so what I want to do for these grounds is if you do via and name it ground, it'll connect vias from top layer to the bottom layer and it'll name it ground. And most of these capacitors should have a grounds very close to it. So this one's close to this, so we don't need to worry about it. I think I ended up putting one there on the original design, so let's go ahead and do that. But we want the grounds go to the ground plane as fast as possible, and I have the shortest path. I want to put one here outside of my Mr. Swirly Eyes logo so that we can generate the ground plane there when we do rats. Probably don't need it, but heck, I'll put another one here. We could put one here, but it won't really help us much. And then, so this is called stitching the power planes, or in this case, since they're both ground, we're just stitching the ground planes. Could have made the top plane a 3.3 volt one. So I'm going to stitch these where there aren't very many grounds, but making sure that they're both over the top and the bottom ground planes. It's a completely optional thing to do. See how this is kind of isolated from the rest of this, so I'll stitch one here. Actually, it would probably be smarter if I move the reset outwards instead. And then I'll push this as close as I can so that this ground plane becomes bigger. So now when we do rats, all this ground is here, which is probably healthier to have. It's kind of hard to see, but if we rip, we have this pad. We want this to have a short path to ground on the bottom. So we're missing this huge ground plane here. And when we do rats, it should be generated. For the voltage regulator, we do want a couple of vias here. 300 milliamps is not a lot of power, but if we had a bigger voltage regulator, then we would have a lot of power flowing through here. And we want to make a nice quick path down there. So we'll connect those. Maybe one here as well. So don't go too crazy. I might be going a little too crazy, but this is fine. I knew that this was going to kind of hurt me, or potentially. So let's try and move this down a little bit. And one is close here. We could put one on the side too. That's fine. Ground here is connected on both sides, so it should be nice and reliable there. I will put one here, one on the other side of this, and one on this lonesome. Oh no, it's connected here. Maybe here on the edge. It's okay if we cover the letters. The thumbsticks and other devices will only fit on one way, so it should be fine. All right, I think that looks good. Let's do rats again, DRC, check to see if any magical errors popped up, and it looks like it didn't, so this should be ready to go.